Hello, I'm Becky Nevin. I'm part of the Deep Skies lab at Fermilab. And today I want to talk about a project I've been working on to create a software suite to test the fidelity of various inference methods that are popular in astrophysics. Why do I feel the need to do this? Well, let's say you are an astrophysicist and you want to run inference to determine the probable values of two of your favorite astrophysical parameters of interest, given some cool data. In our group's work, often these axes are cosmological parameters. Let's say you run your method of choice and you get out a posterior distribution. Now, this is an approximation of the true posterior. So the real question is, how good of an answer is this? Well, in most scientific cases, you won't actually be able to do this, which is look at the true posterior. But in cases where you can make this comparison, such as this project that I'm working on now, you may find that your method is either over or underconfident. And this is important scientifically because in this case, your method is overconfident, which means you are excluding probable regions of parameter space. Just to make you a little bit more worried, recent work has found that many ML inference methods tend to be overconfident. And this is an important bias because, as we know, entire careers in astrophysics rest upon precisely determining error bars. So thinking a little bit more optimistically and further motivating this project, our goal with this project is to focus on the predicted uncertainty and compare that to the true uncertainty from these inference methods so that you can then go out and use these methods with a little bit more informed skepticism. Okay, to build the software suite, which posterior inference methods will I be focusing on? There are many different flavors. They are delicious to different people for different reasons, hence the donut icon. So at least to begin, I will focus on Bayesian inference with sampling, simulation-based inference, and deep ensembles. And there are additionally some hierarchical flavors to some of these methods. Okay, since this project is focused on uncertainty predictions, we will use our group's existing benchmark dataset, which allows us to tweak and carefully control the uncertainty properties of our benchmark dataset. I highly encourage people to go check out DeepBench online if you're looking for any sort of an alternative to the existing MNIST types of benchmark datasets. This software will allow us to curate a dataset that will work across all of the inference paradigms. And with the simple setup, we will be able to calculate the true posterior as well and build an expectation for uncertainty levels. Thank you so much for your time. Please don't hesitate to reach out to me over Slack if you have any questions.